You know, when you look up at the night sky, it's easy to see this peaceful, quiet, almost eternal emptiness. But honestly, that tranquility, it's kind of an illusion. The universe is actually a cosmic arena, just buzzing with immense power and, yeah, sometimes some pretty serious existential threats. So let's explore some of the most spectacular ways the universe could, end it all. So that brings up a pretty wild question. Is the universe actively trying to kill us? Now, I know, it sounds like something straight out of science fiction, but really, digging into this idea helps us understand just how precarious our existence is. It makes you appreciate the incredibly delicate balance that allows us to even be here in the first place.
All right, so here's the game plan. First, we're going to face what I'm calling the cosmic firing squad, gamma-ray bursts. Then, we'll dive into something truly mind-bending, the ultimate ecological catastrophe on a universal scale. After that, we'll look at the dangers of our own ambitions with high-speed travel. And finally, we'll step back and think about our place in the cosmos and what it all means.
Okay, so first stop on our tour of cosmic dangers is one of the most violent events you can possibly imagine, the gamma-ray burst, or GRB for short. Think of this as the universe's ultimate firing squad, unleashing the absolute brightest explosions known to science. So what exactly is a GRB? Well, it's this incredibly powerful explosion happening in some far-off galaxy. The amount of energy it releases is so vast, it's literally second only to the Big Bang itself. I mean, this is the universe operating at its absolute most extreme. These things are so powerful they can actually steer the evolution of entire galaxies, potentially sterilizing huge regions of space and deciding where life can and cannot pop up. Just to try and wrap our heads around that kind of power, think about this. A single GRB, which might only last for a few seconds, kicks out as much energy as our own sun will produce over its entire 10 billion year lifespan. That is just a mind-boggling amount of energy packed into a tiny sliver of time.
And it turns out these things come in two main flavors. You've got your short bursts, which are over in less than 2 seconds. We think those happen when two super dense neutron stars smash into each other. Then you have the long bursts, the more common kind, which are caused by massive stars collapsing on themselves to form black holes. Either way, you're looking at an unbelievably violent cosmic event.
You know, the story of how we even found out about GRBs is pretty fascinating. They were first picked up, get this, by military satellites back in 1967 that were looking for secret nuclear bomb tests. For decades, nobody knew what they were. It wasn't until 1991 that we figured out they were coming from way outside our own galaxy. And the final piece of the puzzle really clicked into place in 2017, when we detected gravitational waves from merging neutron stars at the exact same time as a short GRB, finally confirming the theory. How cool is that?
All right. Buckle up, because we're shifting gears from a known threat to a theoretical one that is, well, it's even more profound. This isn't about an explosion in space. This is about an explosion of space itself, a scenario where the very laws of physics could just change.
The idea is called vacuum decay, and it's based on this concept of a false vacuum. Basically, it suggests that our universe is stable, sure, but it's not in the most stable state possible. And this isn't just a wild guess, it's actually linked to the measured mass of the Higgs boson, which seems to put our universe right on the razor's edge of stability. Think of it like this. Our universe is a ball resting in a little dip on the side of a huge mountain. Yeah, it's stable for now, but there's a much, much deeper valley way down below.
And look, the physicists who first came up with this idea, they didn't mince words about the stakes. They called it the ultimate ecological catastrophe. This isn't just about things getting destroyed, it's a complete, fundamental rewrite of reality. As they put it, not only is life as we know it impossible, so is chemistry as we know it. Everything we understand would just stop. But here's the truly terrifying part. We would never, ever see it coming. A bubble of this true vacuum could just spontaneously form anywhere at any time. It would then expand outward in all directions at the speed of light. As its edge washed over us, reality itself would be rewritten. There'd be no time to do anything, no time to even realize what was happening. Our universe would simply vanish.
Okay, let's come back down to Earth a little, or at least back to dangers that we might create ourselves. As we dream about traveling between the stars, we have to face the fact that there are some immense dangers that come with that dream. So space is, big, like ridiculously big. To get to even the nearest stars within a human lifetime, we'd need to be traveling at a serious fraction of the speed of light. So for the sake of argument, let's just imagine a ship cruising along at half the speed of light.
50%, and see what happens. You might think deep space is empty, right? Well, not quite. It's filled with tiny particles of dust and gas. And at half the speed of light, the kinetic energy involved in a collision is just enormous. Hitting something as small as a pebble would have the same impact as setting off a small nuclear bomb.
And you can see how this scales up, right? A tiny dust particle? That would be a significant hit, but maybe you can shield against it. A pebble? Catastrophic. We're talking a nuclear-level event. And an asteroid? Forget about it. Total annihilation of the ship, the crew, everything. At these speeds, the empty vacuum of space suddenly becomes a very, very dangerous minefield.
So, after all that, what does this tell us? We've looked at these massive, natural threats, these mind-bending theoretical ones, and even dangers we'd create ourselves. What does it all say about our place in the cosmos?
So, to recap, we've got gamma-ray bursts, these incredible, focused blasts of energy. We've got vacuum decay, a hypothetical reset button for reality itself. And then we have the dangers of relativistic travel, the risks we'd bring on ourselves just by trying to explore. Each one really highlights a different kind of peril the universe holds.
And all of this really leaves you with one big, profound question, doesn't it? In a universe with this much raw power, this much potential instability, what does it even mean to survive? Maybe the real marvel isn't the threats themselves, but the incredible fact that amidst all of it, we're here. We exist. We get to witness the grandeur of it all. And maybe that's the challenge, to navigate these cosmic realities with a sense of wisdom and a whole lot of wonder.